In this example, we're going to take a look at experimental probability. Experimental probability uses actual numbers from an actual experiment when calculating the probability versus theoretical probability, which is what you would expect to happen if an experiment were conducted. So in this problem, you flip a coin 100 times, it comes up heads 57 times and tails 43 times. Find the experimental probability that when the coin was flipped, it was heads. So we want to calculate the probability that we are getting heads for this particular experiment. The coin was flipped 100 times, so that's our total. And we're looking for the probability of getting heads, and heads came up 57 times. That fraction can't be reduced at all. So the experimental probability is 57 over 100. If you were to think about the theoretical probability for a minute, there are two sides to the coin, so there are two possible outcomes, and one of those possible outcomes is heads, so the theoretical probability would be 1/2, 1 over 2. When you go through and you conduct an experiment, if you were to continue doing more trials, doing more repetitions, you would expect that the experimental probability would get closer and closer and closer to the experimental. Let me restate that. You would expect that the experimental probability would get closer and closer and closer to the theoretical probability. So with 100 times, we ended up with 57 out of 100. If we flip the coin another 100 times, or another 100 times after that, or maybe 1,000 times or 10,000 times, the more we flip the coin, the more we would expect that the experimental probability would be getting closer and closer and closer to 1/2, to the experimental probability.